Okay, so as I promised, I'm going to show you that, in fact, things of different mass, independent of their mass, would actually fall in the same rate. Okay, and if I drop different things, they'll arrive at the floor at the same time. So I want to show you this, but I need to warn you, I'm a theoretical physicist. So that means this is probably the only time you'll see an experiment in this course, and probably the most practical thing I'll do in the whole year. It's just joking, but also I'm also going to only scramble things in what I can find in the room. That means there's going to be a little bit of difficulty, because for this to really convince you physics does work, and this is the way the world actually interestingly works, that different mass falls at the same speed, I need the mass to be as different as possible. So I need to find sort of the lightest things I can find in the room, and some of the heaviest things. Now the lightest thing is fine. I can, and I think the lightest thing I can find is, for example, a file clip like this. Okay, so this is what I'm going to use, but I don't want to really drop a whole CPU or a computer on the ground. So the best thing I can come up with is a bottle of water. Okay, so I need to warn you also, in order to convince you that this really works, I can't really just drop it for like a centimeter, right, or an inch. That really won't convince you they drop at the same rate. So I need to drop this at pretty great distance. So I'm going to step up on this chair, which makes it extra dangerous. And in addition to that, this is a bottle of water. So it's going to fall from, I don't know, around like 7-8 feet tall to the ground, and it might burst into and I might have to clean up. So this is going to be a really dangerous thing. We'll see how this goes. So there's a good chance this might fail, and I'm only going to do it once because I don't want to risk breaking my bottle twice. So we'll see how this goes. I'll try to capture both sides, and you will see it should land. Let's see if you can see just this land. There we go. All right, so you can see the clip lands there, and I'm going to step up on the chair and make sure I actually am recording. We don't want to not recording at this stage. And we'll give this a try. All right, so and if you will, you can also try to see replay this at slow motion and convince yourself. Oh, one more thing I need to note is I cannot just drop two things, sort of having them holding them in parallel like this, because now the bottom of the bottle is a little bit lower. So even if I drop them like this, they follow the same rate, it will appear as if the bottle arrives at the ground first, right? So I'm going to move this up a little. It's not because I'm shifting this up to have it drop a greater distance, but I'm just aligning them so that they have the same, they start off with the same starting point in terms of heights. They're going to drop the same distance of height. If I move this sort of halfway to the bottle, then it's going to have to drop a little bit more height. Okay, so with all these little footnotes and intricacies out of the way, when we do experiments, we have to be very careful, right? And think of all the details. We'll give this a try. Hopefully on one camera, you'll be seeing my let and go, and the other camera, you'll see it arrive at the ground. And of course, I'm putting a box there just in case things goes wrong. So, all right, here it goes. And 3, 2, 1. I didn't destroy anything, so looks like I'll call that a success. So hopefully that convinces you, and now you know the theory of why that works. So we'll see you in the next lecture.